Okay, great. I'm going to go ahead and get started now. Good morning to each of you, and welcome to this informational webinar that's focused on two nationally supported and recognized programs, PowerAmerica and NextFlex. My name is John Hagwood, and I am a client manager here at GenEdge, which is Virginia's Manufacturing Extension Partnership organization. As an MEP and Commonwealth of Virginia agency, we offer services for further enabling economic development for existing companies at a reduced rate, primarily due to both federal support from NIST through the U.S. Department of Commerce and state support from within our legislature. We are part of the national network of centers comprising over 1,500 staff. Relative to today's call, we've partnered with two MEP centers, one in North Carolina and the other in California. They are known as the North Carolina MEP Group, headquartered on the campus of North Carolina State University in Raleigh, and the California Manufacturing Technology Consulting Team, or CMTC, headquartered in Torrance, California. Both organizations are represented on today's call, and I appreciate their attendance. I'd like to begin today's presentation with an overview map. This map is a depiction of the 14 manufacturing USA initiatives in existence. The federal government under the Obama administration launched these under the name National Network of Manufacturing Institutes, or NNMI. And the primary goal was promoting a public-private partnership model for developing robust and sustainable manufacturing of specific technology areas deemed promising for U.S. growth. In total, the federal government has committed more than $850 million toward these institutes, matched by more than $1.8 billion in other funding and support. The two institutes for review today are circled in red: PowerAmerica, which is on the East Coast, and NextFlex, which is on the West Coast. First, let's review PowerAmerica. PowerAmerica's mission is to develop advanced manufacturing processes and designs focused on the adoption of wide-bandgap semiconductors. I'll spend more time discussing the material specifics, but for now, one of the important factors is improving energy efficiency, especially when compared with traditional silicon-based technologies. All of us are familiar with silicon. The fact that we're attending this webinar is one simple example of our exposure and exploitation of this well-known and heavily used material. In practice, PowerAmerica is a public-private partnership supported by the Department of Energy with two main objectives: reducing energy consumption and creating U.S. manufacturing jobs through wide-bandgap semiconductor technology. By now, you may be asking, what is a wide-bandgap semiconductor? Wide-bandgap semiconductors are devices which use more advanced materials like silicon carbide or gallium nitride as their foundation. These materials have physical properties making them more superior than traditional silicon, especially for power electronic form factors. Specifically, key performance enhancements such as higher operating voltages and faster switching frequencies are ideal device characteristics and circuitry capability, especially operating in the plus 600 volt range. The advantages of smaller size and superior thermal properties allows overall system level improvements when displacing silicon with these wide bandgap devices. These system level improvements come with an overall cost reduction rather than increase because of efficiency gains due to reduced cooling and size and weight requirements. Those benefits are well noted and important. However, to gain a better appreciation for the real impact and interest in the technology and its benefits, let's watch a brief video overview featuring PowerAmerica's Executive Director, General Nick Justice, and former Deputy Director, Dr. John Muth.
About wide-bandgap semiconductors and how they've revolutionized lighting. When I was a graduate student, there were no blue LEDs. Today, blue LEDs, white LEDs have really changed the energy that's being consumed across the country. With power electronics, we have the same opportunity. By making these very efficient chips out of wide-bandgap semiconductors that can control the power, we can save power in motors. We can have windmills and solar inverters for photovoltaics be much more efficient, and we expect to see tremendous energy savings, and it's clean energy. So we'll be able to have accessibility to energy to people in a clean way that will impact their quality of life.
That particular video is located on the PowerAmerica website, and you are certainly encouraged to go view it and review it again at the following URL. PowerAmerica's focus on power efficiency through wide bandgap technology is the beginning of a paradigm shift with the expectation of having a dramatic and positive impact on the U.S. economy and our environment. Let's review a few industry and market examples where wide bandgap semiconductors have the potential for realizing energy efficiencies. Applications such as compact adapters are used for charging consumer electronics, which can be significantly reduced as compared with existing technology implementations. Electric and hybrid vehicles and their corresponding charging stations, which can minimize energy losses and potentially provide energy back onto the grid using bidirectional technologies. This application is currently seeing a tremendous amount of focus as manufacturers are planning scale-out capability for delivering these vehicles in mass numbers in the coming years. Also, improving the output and control of traditional motors, which ultimately will drive down maintenance costs and prolong the uptime of their usage. And finally, reducing the space and footprint requirements for very large data centers based on enhanced power energy uses is just another simple example of the benefits that wide bandgap semiconductors offer in the IT space. So, how and where exactly is PowerAmerica progressing forward in activities for improving the technology acceleration and adoption of wide bandgap semiconductors? There are 5 key areas of interest where the Institute is leading and partnering with its members for making improvements. The first, and often the most important for many companies, is cost. And all successful businesses remain maniacally focused on cost and expense management as a means of simply doing business. In this arena, much attention is given to improving the overall substrate manufacturing processes, which ultimately are a primary driver of the device and chip. Just as with silicon substrate technology and process yield learning, increasing wafer volumes while improving substrate performance is a key objective for realizing the required cost reductions, and continuous work is ongoing and at this foundational level. Reliability and performance are 2 other very important aspects of wide bandgap semiconductor adoption and proliferation. They are important because their implications span the entire design, development, and manufacturing cycle, and the level of test and measurements required for detecting and correcting problems is significant. So, the Institute and its members are actively working on projects for addressing those aspects of device, package, and integrated system performance. Now, I'll briefly discuss integrated supply chain on the next chart, but last and certainly not least is the focus on educational initiatives like today's webinar, which are designed to reach out and provide awareness to many through intentional academic and workforce development activities. So that was a very brief summary of how the Institute is working to accelerate the adoption of wide bandgap semiconductors into broader markets and industry. Now, a very brief overview of the integrated supply chain. PowerAmerica views the power electronics supply chain essentially as 6 distinct segments, each focused on a set of specific deliverables as depicted in this funnel chart shown in front of us today. As you read the chart from left to right, one of the messages is the quantity or magnitude of the supply chain growth. So, for example, on the far left, there are few silicon carbide and or gallium nitride foundries. This is the level 1 segment within the supply chain. While on the very, very far right, you can see that there are many product users known as level 6 who represent the system level integrators employing wide bandgap semiconductors into their customers' required form factors. Now, in between these two bookends, if you will, are in many cases what we're calling the small and medium-sized enterprises. And it is in this space where the MEPs, Gen Edge, North Carolina MEP, and others, including TMAC in Texas, are working to provide awareness that will hopefully lead to access. We believe these are the segments where global competition will continue to be extremely fierce, and positioning our U.S. supplier base in these spaces we believe is a huge need. So one objective of today's call and our ongoing MEP outreach is to assist you, the SMEs, in your understanding and undertaking of providing critical products and or services ultimately within the level 6 product user segment. So I've shared one reason why companies might consider participating with PowerAmerica. What are some others? Well, one obvious reason is simply the networking. What do I mean by the networking? The potential for a small or medium business to increase their customer or even their supplier base. Beyond the obvious business growth benefit, there are many technical advantages, including receiving hands-on instructions and accessing wide bandgap semiconductor experts. Ideally, the required time and resource investment for improving both business and technical would yield a more global competitive position and strengthen the U.S. base of product and services provided in these industries served using power-based electronics. Also depicted on the bottom half of the chart are the current members of PowerAmerica. Many companies and organizations listed are fairly obvious. For example, Lockheed Martin, Wolfspeed, and XFAB, which XFAB now currently is providing access to silicon carbide MOSFET and diode process capabilities, which is a great achievement for that team there in Texas, as well as companies like GM and ABB. It makes sense why their participation is very straightforward. However, someone on a call might ask the question, why would a company like John Deere benefit from joining PowerAmerica? Well, that's a very interesting and intriguing question. So turns out that John Deere demonstrated by replacing their traditional all-diesel front loader with a hybrid form using IGBT electronic circuitry, they could maintain identical performance of the tractor with a greater than 25% fuel efficiency and a quieter engine. So one of their objectives in working with PowerAmerica is extending these efficiencies by employing silicon carbide wide-bandgap devices. So here's a case where a non-traditional electronic company benefits from the technology capability offered by wide-bandgap electronics. Let me pick another example. United Technologies Research Center. United Technologies Research Center is working on improving the efficiencies of HVAC units installed within residential communities. They recognize that every year about 5% of the units which exist within the United States are replaced. That 5% translates to about 5 million units a year. And they are performing research and development to improve the compressor efficiency within those units utilizing wide-bandgap semiconductor. The desired result is that those newly released wide-bandgap semiconductor HVAC units will be more efficient, and that efficiency improvement could lead to reduced utility cost, which most Americans could really appreciate having that capability at their fingertips. So those are just two examples of companies who are working to employ wide-bandgap semiconductors in what might be considered a non-traditional semiconductor application, if you will. Now that we've discussed why people should participate, let's briefly review how companies and organizations can participate in PowerAmerica. And there are 4 simple approaches toward gaining access. The first and most straightforward approach is just free monthly webinars and outreach events like today's informational session. And PowerAmerica maintains a schedule of activities that are free and open to the public. Those activities are listed on their website. I attend their activities very often as a means of remaining aware of the capability and progress that is being made continuously in the wide-bandgap semiconductor space. So that's the first and most simple way to participate. The second way is what is termed nearly free. And these nearly free events typically have a very nominal fee, sometimes just to cover the food that is provided during the event. Similar, for example, to the annual session that was held this past August in Raleigh, where folks from all over the country came in to learn the latest activities on PowerAmerica's roadmap. And those events also are advertised on the Institute's website. The third category is really what we call by project. And by project means highly specialized assistance that the Institute can provide in the form of consultation-like services. And by doing so, that allows a company or an organization to get very specific hands-on insight into issues and potentially problems that they're struggling with as they're trying to help develop their capability in the wide bandgap semiconductor space. And finally, it's what is called the membership fee option. And the membership fee option grants a company and organization access to funding opportunities and intellectual property. Now, the fees that are paid as a part of membership are based on company size. The upside is companies can seek funding as members one of two ways, either through the annual call for projects, which the RFI went out this past August, or the Open Innovation Fund. Now, both funding opportunities fund up to roughly the maximum amount of about $225,000 per project. And they do require a 50% match in kind, and companies are able to retain their IP while gaining access to the IP that the Institute has made available. The simple difference between the Innovation Fund and the Call for Project is the Call for Project is on an annual basis with a list of projects that the Institute has under consideration, while the Open Innovation Fund is available year-round and applications can be submitted at any point in time. So I'm sure with this review there are questions regarding PowerAmerica. I will ask, however, if we could hold those questions until the end of the presentation. Now, I'd like to switch to the NextFlex Institute. Formed in 2015 through a cooperative agreement between the U.S. Department of Defense and FlexTech Alliance, NextFlex is a consortium of companies, academic institutions, nonprofits, and state, local, and federal governments with a shared goal of advancing U.S. manufacturing of flexible hybrid electronics, or FHE. The Institute's primary hub location is in San Jose, California, although they work with other universities across the country, and I'll give you a picture of that in just a few moments. The overall vision of the NextFlex Institute is integrating three disparate capabilities: thin silicon manufacturing, printing, and electronic assembly, those three into a seamless ecosystem promoting and producing FHE solutions for a variety of industries and applications. By adding electronics to new and unique materials that are part of our everyday lives, in conjunction with the power of silicon ICs to create conformable and stretchable smart products, FHE is ushering in an era of electronics on everything and advancing the efficiency of our world. Now, what exactly is FHE? FHE, or flexible hybrid electronics, is a process which combines technical aspects of the electronics and high precision printing industry. Specifically, it is integrating very thin silicon die on the order of less than 50 microns thick into a flexible, conformable plastic film substrate for enabling advanced electronic capability, particularly in the area of sensors. Now, FHE allows the manufacturability of sensors that can be lighter in weight, conform to the curves of a human body, or stretch across the shape of an object or structure. One of the key benefits is the ability to preserve full operational characteristics of electronic traditional circuitry. FHE will bring electronics out of the box, and by bringing them out of the box, it will integrate them directly into wearable, manufactured items and other form factors. Now let's take a look at a very few brief FHE examples. The top left picture illustrates a comparison between a standard rigid PCB form factor and a flexible, conformable FHE test sample. As we look to the right, we see a thinned, integrated test sample that in that form can be used for many sensing applications. And if you notice, the radius of curvature as demonstrated by the person holding the sensor is extremely flexible as to what it is able to achieve. Finally, the bottom center image is the depiction of a wireless body temperature circuit, which in an ideal configuration would sense temperature at multiple points, transmit those data wirelessly to a device or system, providing real-time and safe data analysis for the subject or subjects which are under test. And these are just a few of the envisioned FHE examples that are under discovery and development through the Institute. Now let's take a very quick look at some of the market opportunity. The market opportunity for FHE is extremely sizable, with many of the Internet of Things, IoT-like devices believed to have a very strong presence, especially in healthcare, in the healthcare industry, particularly where quality and reliability of life and death situations are critical. Additionally, opportunity may also exist in some limited cases where there's a shortage of medical professionals and staff that are available to visit with a patient at their location. And so this opportunity is something that we believe and NextFlex believes will continue to drive demand within the overall supply chain, particularly within small and medium businesses who are supplying some of the larger companies. And hopefully it will drive larger companies to continue to work with smaller companies to help them realize that demand and that capability. And for this call, it's important for us to realize that opportunity for participation is not excluded to just large corporations, but small and medium-sized firms are welcomed and encouraged to participate in the development of FHE, specifically in working with the NextFlex Institute. So let's take a very quick look at some of the companies who are participating in the Institute. So here is a chart of the current members that are participating in the NextFlex Institute. And as you can see, there are varying company and institution sizes that are actively engaged. Tier 2 companies like DuPont, who are focused on clothing. In particular, one example is a Formula One racing suit, which would feature stretchable electronic inks and films that transform ordinary fabrics worn by race car drivers into active, connected, intelligent garments transmitting biometric data including heart rate, breathing rate, and muscle tension. Another example is a Tier 2 company, well known, called GE. And they are developing wireless, wearable EKG devices, which will reliably communicate between patients and physicians. And these devices should provide instant and constant readings of how the body is responding to various conditions. Even in the Tier 3 space, companies like American Semiconductor, who is focused on developing lighting and sensors on an ultra-thin FHE microcontroller that can be wrapped around something as small as a pinky. And so the technology integration activities required to execute and deliver that particular form factor is something that American Semiconductor is leveraging the capability within the NextFlex Institute to bring to pass. And so these are just a few examples of some of the great work and ongoing development, and I would even say further exploitation within the FHE arena. So, how can companies get involved and participate with NextFlex? Well, first, similar to PowerAmerica, there is awareness and educational briefings. Number 2, they offer training on site as well as remote. There are hubs both at Purdue University as well as Georgia Tech. Also, just networking, connecting with supply chain partners, understanding their needs and their requirements, and working collectively with those larger corporations to help meet those. And finally, just by adopting the FHE manufacturing technology itself and bringing that capability into a form factor and into a business environment that works well for that particular small and medium business. So, in summary, FHE is definitely a manufacturing capability. It is enabling new and innovative devices, and certainly a wave of new products and services is coming and creating what is believed to be additional demand. So the encouragement is that we would be aware of it, that we would prepare for it, and that we would take financial opportunity of the FHE option, which, similar to the PowerAmerica option, also has call for projects on an annual basis, and they also provide funding up to about $225,000 per project as well. So, in conclusion, just let me inform each of you of a survey that we're asking for your input. It's very straightforward and should only take about 5 minutes. And I just like to thank you in advance for your participation. And now I'll open it up for any questions that you may have. Simply indicate inside of the team room that you have a question, and I will take them in the order that I receive them.
All participants are muted, and they can unmute themselves. All participants are muted.
Okay. Are there any questions at all from the team? So again, just to be clear, if anyone who might have a question, again, just click the request to speak, and I will open up the line so that you may ask your question. Okay, well, if there are no questions, I'd like to thank again each one of you for attending our webinar. This is our first informational webinar. I'd like to thank my colleagues from PowerAmerica and from NextFlex and from NIST for attending. And please take a few moments and just participate in the survey. And if there's nothing more, we'll end the call now. Thank you very much.